Hello dear students, I am Professor Anindo Das from Achievers, and in this video we will be discussing some fundamental concepts of non-equilibrium thermodynamics. So at first you need to have a conception of non-equilibrium thermodynamics and how is it different from the normal thermodynamics that we have already studied. So, non-equilibrium thermodynamics is a branch of thermodynamics that deals with physical systems which are not in thermodynamic equilibrium. In first law of thermodynamics and second law of thermodynamics, we have studied systems which are at the state of equilibrium. We have studied the concept of spontaneity, we have studied the concept of equilibrium. But here we are dealing with physical systems that has yet not attained the state of equilibrium. Almost all systems found in nature are irreversible and are not in thermodynamic equilibrium. That's quite natural. We already have that conception that not a single process will attain absolute reversibility. They can approach reversibility, but attaining absolute reversibility is not possible. So, in reality, all the natural systems they are irreversible in nature and they are not supposed to attain the state of equilibrium. So, at first you need to know flux and gradient. This is very important. In an irreversible process, we define these two terms, these two physical parameters, flux and gradient. What is flux? Flux is basically the quantity which is transported, and the gradient is basically the force, the driving force which causes this flux. Okay, and this is represented by J equal to Lx, where J is the flux, X is the gradient and L is the transport coefficient. A transport process is taking place over here, so L is the transport coefficient. If we tabulate, then if flux is heat, then the driving force is temperature. If flux is mass, then the driving force is concentration. If flux is momentum, the driving force is reduced mass. If flux is electrical current, then the driving force is the electrical potential difference. So, we all know that if there is a temperature difference, then there will be a flow of heat. If there is a concentration difference, then there will be a flow of mass. We know this is the process of diffusion. If there is a difference in electrical potential, then charge will flow, as we are already acquainted with Ohm's law. And similarly, if there is a gradient of reduced mass, then obviously there will be a flow of momentum. So, now if we are dealing with multi-component system, then this equation J equal to Lx that has to be expanded, and see it is expanded in this manner. J equal to Li1 x1 plus Li2 x2 plus Li3 x3 up to Lin xn. Here I, basically this I is basically 1, 2, 3, etc. This equation is known as linear phenomenological equation. It is an expanded linear phenomenological equation. Lii is called the primary phenomenological coefficient if these subscripts are same, say 2, 2, 3, 3, etc. Then this is primary phenomenological coefficients, and Lij, where I is not equal to j, is called Onsager's phenomenological coefficients. And by Onsager's analysis, we find that Lij is often equal to Lji. So, this is the fundamental concept regarding non-equilibrium thermodynamics. From here, we can have a very broad branch of thermodynamics that is under the jurisdiction of systems where the equilibrium is not attained, and this is usually said to be non-equilibrium thermodynamics. So that's all, students, for today's video. Bye bye for now.